Expansion of space. Yes, this is the topic of discussion. Expansion of space. What is the meaning of this? Space itself expands or something else? Yes, we are talking about expansion of space. That means space itself is expanding. It is not like that objects are moving through the space and with time distance is increasing between the objects, and that's why we are saying that space is expanding. Not like that. If you consider a balloon, say there are few dots on the outer surface of the balloon, and when the balloon inflates, in that case what happens? The volume of the balloon increases. The balloon inflates, that means volume of the balloon increases with time. So what you would observe in that case? The distance between the dots would start increasing. So what is the conclusion from this? Here the dots are not actually moving over the surface of the balloon, but the balloon itself is expanding or stretching. Here stretching means the expansion of the balloon. Since the surface of the balloon is stretching or expanding, that's why the distance between the dots are increasing over time. Okay, so this way the expansion of space can be explained. Is there any theory which supports this expansion of space? Yes, there is one theory. That theory is known to you, known as Einstein's general theory of relativity. This concept is rooted in that theory. If you study general theory of relativity, then you would see that according to that theory, the space we live in is not static in nature. It is not unchanging stage where events happen or events occur. It is a changing stage, not unchanging. It is a changing stage. Means the nature of the space itself is dynamic. You know that if you study theory of relativity, general theory of relativity, then you would see that space can bend, warp, these terms you would see there. Means actually space-time, that term is mentioned in the theory of relativity. Bending, twisting, warping of space-time. And according to that theory, you know that whenever there is mass and energy anywhere in the space, then the effect of that mass and energy, either mass or energy or both, okay, the effect of that is that warping of the space-time around it, and warping is more if the mass plus energy, this amount is more. Okay, so that is only warping of the space-time, but space itself, you would find stretching of the space itself. And this theory was given by, proposed by, means theorized by, better to say theorized by Georges Lemaitre in 1927, in the year 1927, and later in the year 1929, just after 2 years, Hubble confirmed this by observing the increasing distance between the galaxies by using his telescope, Hubble telescope, which is known as Hubble Space Telescope. You know that thing. Okay. By observing the increasing distance between the galaxies, he concludes that the expansion is, our universe is expanding over time. And that's why the distance between the galaxies are increasing over time. It's not like that galaxies are moving away from each other. That's why distances are increasing. It's the space itself. Means it's the universe itself which is expanding. And that's why we are observing that increasing distance between the galaxies. Again, if you study CMB, that is cosmic microwave background radiation, then you will see that with time the wavelengths, means CMB is what? This is nothing but a faint radiation. It is afterglow of the Big Bang. Okay, so a faint radiation is observed, which is known as CMB, and it has been observed that the wavelengths are going on increasing with time. So there is a cooling effect, and by analyzing these things, physicists concluded that the universe is expanding. If there is an expansion of the universe, means if there is a stretching of the space itself, then only the wavelengths, the length of the wavelengths, means actually wavelengths, are increasing. They are also stretching. Since space is stretching, therefore the wavelengths of the CMB radiation are also stretching. And by observing that stretching of the wavelengths of CMB radiation, physicists analyzed those things and concluded that yes, the universe is expanding. That means space itself is expanding. So this is what? This is supporting evidence. Okay, still research is going on in this field. You know that this research is still not complete. Many things still remain unknown. Since many things still remain unknown, that's why research is going on in this field. This is the field of cosmology. And the study of this expansion of space is crucial for the understanding of the structure of the universe, the origin of the universe, the evolution of the universe. And also the fate of the universe can be predicted if there is a proper understanding of the expansion of space. You know that there two theories are there. Theory of Big Rip is there, and theory of Big Fridge is there. According to Big Fridge theory, what happened at the end? At the end means I am talking about future of the universe. The atoms will torn apart, the galaxies will torn apart, and you will get the coolest temperature in the universe. Okay, temperature, if universe expands, then temperature must decrease. Which time? Okay. And there is a phenomenon of Big Rip. These are nothing but theories, okay? These are the predictions by the physicists about the future of the universe. Okay. Anyway, so this was all about the stretching of the space itself, okay, or the expansion of the universe. Both are same. Okay. Anyway, so this is the end of this video. Thank you. Thank you for watching this video.